Here in the Pacific Northwest, we're used to living under the shadow of a volcano, or several, actually. The Cascade Volcanoes are just a short drive away from Portland, Oregon, where I live, and they're pretty well known. Mount Hood, Mount St. Helens, Mount Adams, all really beautiful, very dangerous. The United States Geological Survey monitors these volcanoes closely. They have all kinds of cool equipment like tilt meters that measure the small changes in the height of the volcanoes, seismometers that listen for earthquakes that might be caused by magma moving underground, and gas sensors that sample the air around the volcanoes looking for changes in the amount of sulfur dioxide gas. All of this monitoring has paid off in the past. In 1980, USGS scientists were able to predict that Mount St. Helens would erupt 2 days in advance, and those predictions saved lives. Only one person died in the eruption because scientists were able to warn people in time to get out of the way. But lately, the USGS has been getting some weird signals from the Cascade Volcanoes, and they don't know what to do about them. Every once in a while, the volcanoes seem to pulse, growing a little bit in height and releasing lots of heat. It doesn't happen to all of them. So far, only Mount Hood and Mount St. Helens have shown signs of life, but nobody knows why. And it could mean something really big is coming. So here's what's happening. It all started back in 2021. Scientists noticed that the ground near Mount Hood had started bulging at an angle. Now, this wasn't anything new. Scientists have been watching this bulge slowly form since 1976. But back in 2021, it suddenly got steeper. Basically, the mountain had been inflating like a balloon for 45 years, and then suddenly the balloon was getting bigger faster. This worried scientists because the shape of this bulge looks kind of like a pregnant belly. That means the magma pushing up from deep inside the Earth isn't evenly distributed. Instead, there's a big blob of it right underneath the bulge. And if that magma ever did break through to the surface, it would be a huge eruption, like the biggest one in the history of the Cascades, even bigger than the one that made Crater Lake. And then there's Mount St. Helens. It erupted so violently in 1980 that it blew a giant hole right through the top of the volcano. Since then, scientists have been watching that hole carefully. Back in 2021, they noticed that the floor of the crater had risen by 50 feet. Then, in April 2022, it rose again, this time by over 300 feet. So what's going on? Why are these volcanoes suddenly waking up after being quiet for hundreds of years? Well, the first step to answering that question is figuring out how tall the volcanoes are in the first place. Now, you'd think this would be a pretty easy thing to figure out. After all, they're just pointy things. You can measure their base and then use the Pythagorean theorem to calculate their height. But turns out, that's not good enough for scientists. If you measure the height of a volcano in the traditional way, it turns out that Mount Hood is either 13,950 or 14,110 feet tall. That may not sound like much of a difference, but for a volcano, that's like 2%. And when you're studying volcanoes, even a 2% difference is really important, because it could mean the difference between a small eruption and a big one. You see, the volume of a cone depends on its height, its radius, and also the depth of its roots. If you think about it, a volcano is basically just a big pile of broken rock and ash that happens to be shaped like a cone. So the total volume of a volcano is just pi times the radius squared times the height plus the volume of the roots. And the deeper the roots go, the more stable the volcano is. A big root system acts like the legs on a tripod. They spread the weight of the volcano out over a bigger area so it won't collapse. But here's the thing, no one knows how deep the roots of these volcanoes go, so scientists are working hard to figure it out. One team of researchers recently presented a new method for measuring the volume of a volcano using airborne radar. They flew a plane full of radar equipment over the Cascade Volcanoes and created detailed maps of their shapes. These maps allowed them to accurately calculate the volume of each volcano for the first time ever. But even though this paper came out earlier this year, it hasn't really helped scientists understand what's going on. For one thing, the new measurements of the volcano heights didn't really change anything. Mount Hood is still either 13,950 or 14,110 feet tall. For another, The radar measurements don't tell us anything about the roots of the volcanoes. They only tell us about their shapes. That's why scientists are still searching for answers. One team of researchers thinks that magma is rising up inside the volcanoes and pushing them taller. Magma is less dense than solid rock, so it makes sense that it would push the land above it upward, but there's no way to prove it. Scientists can't just stick a drill into a volcano to take a sample of the magma. It's way too hot. Instead, they're trying to analyze the gases coming out of the volcanoes to see if they contain dissolved carbon dioxide. Carbon dioxide is one of the few things that's both a liquid and a gas at room temperature. So if scientists can find dissolved carbon dioxide in volcanic gases, it would be evidence that the magma is rising up through the rock, carrying carbon dioxide with it. But so far, this test hasn't turned up anything interesting. Another team of researchers thinks the ground is bulging because of something called anelastic creep. Imagine you have a block of jello and you poke your finger into it. If you leave your finger there long enough, the jello will eventually move around and your finger will sink all the way down. Now imagine that instead of jello, you're poking into a big pile of wet sand. Your finger will still sink down eventually, but it will take much longer. Anelastic creep is similar to this. It's the idea that rocks can deform over time without actually flowing. Basically, the rocks are so hot that they're kind of gooey. So even though they look solid, they're slowly deforming under the weight of the volcano. Over millions of years, this could cause the whole volcano to slump over, but it shouldn't cause the kind of sudden bulging that scientists have observed. So for now, nobody really knows what's causing the Cascade volcanoes to grow. But it's not all bad news. Most scientists agree that whatever is happening, it's not causing the volcanoes to become more dangerous anytime soon. The Cascade volcanoes aren't like the volcanoes in places like Italy or Japan, where cities are built right up against the slopes. The nearest city to Mount Hood is about 25 miles away, and the nearest city to Mount St. Helens is almost 100 miles away. Plus, the Cascade volcanoes aren't even due for an eruption yet. Volcanic eruptions happen in cycles. Right now, the Cascade volcanoes are in between eruptions. The last big one happened 198 years ago. Before that, it was 500 years ago. So we've got a little bit of time before the next one. Still, scientists want to keep studying the volcanoes just in case. It would be nice to have a little more warning before the next big eruption, just like Mount St. Helens in 1980. In the meantime, if you live in the Pacific Northwest, just remember, when you're driving through the mountains, if the roads are closed, turn around and go home. Don't try to drive through. Thank you for watching this episode. If you liked it, you can help us keep making more by joining our community on a crowdfunding platform. You'll get access to a bunch of perks like blooper reels, behind-the-scenes videos, and even our private server where we hang out. Thank you for watching. See you next time.